So, Heinemann Higher, Unit 1 Straight Line, Exercise 1O, Question 5. It says ABCD is a square, gives the coordinates of A, 3, 4, gives the equation of the line that forms the base of that square there, y equals half x, and then there's three parts. A, find the equation of the line AD. Right, so, find the equation of the line AD. I think I'll take a note of that first of all. I've got y equals a half x. I'm not going to use that later, I'll give it a name. Right, AD. To find the equation line AD, I'll need to know two things. A point on it, got it, and its gradient. Well, since that's a square, that means that ADC, the corner of a square, must be a right angle. I don't know if I need to make a statement for that. Which means that AD is perpendicular to DC. I'll put a wee note first of all. AD is perpendicular to DC since ABCD is a square. Which means I can find the gradient of AD, the missing thing for the line, by comparing it to the gradient of DC. Now I know DC. I've got the gradient of DC is a half, extracted immediately from that. Which means that the gradient of AD is going to be the whatever multiplies it to give -1, so it's the negative of the reciprocal of that. So the gradient of AD, is going to be -2. Just leave that there. Right, now for the equation. Y minus B is x minus A. I'll just put a wee note again. The gradient's -2, and the point I'm using is the point 3, 4. I know a point on it, I know its gradient, so feed it in. Y minus the y coordinate. Y minus 4 is -2 times x minus the x coordinate. That's perfect. That will go straight into the form y equals mx plus c because it's all integers. Y equals -2x plus 6 plus 4, so that's plus 10. Give that a name because I will be using it. I'll call that 2 because that's my second equation that I've got on the page. Right, that was part A. And so part B, find the coordinates of D, the intersection of those two lines. Right, well, so to find point D, you're going to substitute the two equations. That's this line and this line. So that's 1 into 2. Substitute 1 in 2. So that means you write down equation 2, only in place of y, you're going to write a half x. So half x is going to equal -2x plus 10. Right, the first thing to notice with that is it's got fractions. Avoid fractions, nasty things, double everything. So that means I've got x is -4x plus 20. Swap sides. 5x is 20. Solve that. X is 4. And then substitute it in to find y. So substitute x equals 4 into whichever's more convenient, which will be number 1. In which case it's going to read y equals a half of 4. I should underline that just now. Which means y equals 2. So D is the point 4, 2. And then the third question was, find the area of that square ABCD. Well, that means work out the length of one of the sides. So since it's a sloping line, I'll have to use Pythagoras, so I'll be AD squared. But handily, because to get the area of a square, all the sides are the same. So AD times DC is the same as AD squared. So I won't need any square roots, AD squared will do. So AD squared, again, it's a sloping line, so using Pythagoras. Call that the distance formula, if you will, which just means the the vertical horizontal sides of that will be the difference in the x's and the difference in the y's. I'll just put them down that way though. The difference in the x's and the difference in the y's for the two shorter sides of that triangle. So, difference in the x's from A to D. Well, D is at 4, A is at 3, so that's 4 minus 3. Y coordinates. D is at 2, that's at 4, so 2 minus 4 squared. So that's going to be 1 squared plus, if you like, -2 squared. So that's 1 plus 4, which equals 5. Which means that the area of the square is going to be 5 units squared. Oops. And that's the answer to question 5.